The audio restoration task. Firstly, the catamaran, which contains an extremely loud sail flapping in high wind.
The cat for part of a deal for flying boat.
So in class I demonstrated using the sidechain feature of the audio compressor, but the real learning task here is not just audio restoration, but what should have been done during the location shoot, which was choose the appropriate microphone for that specific shoot. High wind, flapping sails. The problem here is that an omnidirectional microphone was used as a clip-on mic when a cardioid polar pattern should have been used on that person's, on that actor, the person that's speaking. And that would help reduce the background noise, wouldn't eliminate it, but at least would focus on that person's voice. So here we have the challenge.
The cat for part of a deal for flying boat.
Of how can we suppress the noise of the flapping sail? Well, we're not going to be able to delete it, but maybe we can suppress the sound. Now I've got the compressor and I'm about to use the sidechain. Now you can have two frequency points here. I've got 7.7 kilohertz. You can solo to see what that area sounds like.
Part of a deal.
Here I have a lower area, 5 kilohertz. Let me just bring it right down so it sounds dramatically different. So we're in the range of his voice at around 5 to 800 hertz. I mean, that's a strong area of that person's dialogue in terms of frequency.
Part of a deal. Part of a deal. Part of a deal.
So we don't want to select that narrow zone.
Part of a deal.
Because otherwise when he speaks, he's going to trigger the compressor.
Part of a deal.
What we're trying to find
Part of a deal.
is where is the main energy of the flapping wind sound.
Part of a deal.
So turn that off. Let us listen to the higher area.
Part of a deal. Part of a deal. Part of a deal.
Now when we end up in the range of 3 kilohertz to 7 kilohertz, we're in the consonant, that's sound of spoken voice or a singer with that consonant sound. So we need to be mindful of that as well.
Part of a deal for flying boat.
Flying, that area. But anyway, let's see what this, how it works with the compressor. So this is the monitor. So I'm monitoring what I'm filtering. The idea here is that this filtered narrow band area will trigger the compressor when a strong signal around 3 kilohertz is detected. Right, now you see the amount of gain reduction. I have quite a high ratio, and the threshold you would adjust accordingly. The idea is when he's speaking, you don't want the compressor to be working if possible.
Part of a deal for flying boat.
Let us bypass that.
Part of a deal for flying boat. Part of a deal.
So his voice is being affected here. So let me raise the threshold level.
Part of a deal for flying boat.
It's very important to adjust the attack. If the attack is too slow, then the sound of the flapping sail will not trigger this compressor, because the flapping sound actually begins, the sound of that flapping sound, the beginning of that sound is very fast and at a high level. So if the compressor attack time is too long, the compressor is going to miss capturing the level of that sound.
Part of a deal.
Compared, again, play that.
Part of a deal.
Compare that to a fast attack.
Part of a deal. Part of a deal for flying boat.
Bypass it.
Part of a deal for flying boat.
Okay, it's very subtle. So again, you need to experiment with the attack time and the release time ratio. These different parameters are going to give you different results.
Part
That's bypassed.
of a deal.
So this is the original.
Part of a deal. Part of a deal.
Compressor on.
Part of a deal. Part of a deal.
Let's compare that to choosing a much lower area in just above the bass, the low mid area, 270 Hertz.
Part of
Again, it sounds like this.
Part of a deal. Part of a deal. Part of a deal. For flying boat.
Now his voice is actually in this area, and it's triggering the compressor.
Part of a deal. Part of a deal. Part of a deal. For flying boat.
So you can notice a huge difference in level.
Part of a deal. Part of a deal. Part of a deal.
Compare that to this area as the trigger, this narrow band of frequencies at 3 kilohertz.
Part of a deal.
This is the original.
Part of a deal. Part of a deal. Part of a deal. For flying boat.
So his voice is not being pulled down like it was when I had selected 271 Hertz as the trigger frequency. Bypass.
Part of a deal. For flying boat. Part of a deal. For flying boat.
Notice how his voice is actually being reduced a lot. So that's not a good area to look at. Okay, so this is sort of working a little bit. So I could raise this maybe to around 6 kilohertz. Solo that.
Part of a deal. For
And again, I'm listening, well, monitor, now I'm listening to this area.
Part of a deal. For flying boat.
Let's try that, turn the monitor off. So this will trigger. The top one is not inserted, so this one is operating now.
Part of a deal. For flying boat. Part of a deal. Part of a deal.
I think this one works slightly better. Bypass.
Part of a deal. For flying boat. Part of a deal. For flying boat.
So it's a very time-consuming exercise. Now what you can consider is combining this, engage the equalizer, and focus on the extreme high frequencies. You could either experiment with filtering the high frequencies using a low-pass filter that allows low frequencies to pass through. You need to turn it on. You can see the shape of that slope, which you can alter. Make it a sharp slew rate. Okay, bypass this.
Part of a deal. Part of a deal.
Bring the filter point down further. Bypass.
Part of a deal. Part of a deal. Part of a deal. Part of a deal.
Now that's sounding better, but if I reduce this any more, then I'm into the area of consonants around 3 to 7 kilohertz.
Part of a deal. Part of a deal.
So you can consider combining both compression with the trigger frequencies being the side chain. Side chain is basically acting as a trigger for this compressor to work, and then combine that with equalization.